to stars, okay? Because near my bed there was a window, and I used to stare at the stars and the moons. And my mom used to ask me what you are looking at. And I was saying, yeah, I want to go to the stars. But that was a child's dream. Later I realized that astronauts can go there, but they don't do science. So I realized, oh, it's not something I want. But the actual dream started in the physics department itself. So I did my integrated masters in physics from 2012 to 2017. And in 2015, we had courses. So the dream starts with curiosity. And since you all are taking bachelor's and master's degree courses, you must realize that your professor does not give you the knowledge which are already in the book. They try to initiate that curiosity in you. I remember some questions. Like one question Mukul asked me, and because of that I was sleepless for one night. The question was, he was teaching us electricity and magnetism, and he asked us question, what will happen if the refractive index becomes negative? What will happen to the skin type? And we left the class with that question. And it took me almost one night to understand that, okay, that will make the matter invisible. The next day we went to him and then he said, yeah, that will make it invisible. So you always have to be curious if you want to pursue research. Okay? So the main fire starter for all this journey was this workshop. This was 2015, when first time from the physics department, our batch went for the Chanchal Kumar Memorial Majuda workshop. And the person responsible for this was our Mabu sir. So this was the time when Mabu sir recommended us to go to this workshop. You can see some familiar faces. This is Nargesh, she is here. One person was also from I believe, yeah, this. She is right now a primary teacher, and then there I am. So in this workshop, this was 10 days workshop, and I get to know that if I had a curiosity for research, I wanted to do, but I didn't know how to start it. And in this workshop, I met a PhD student. She was from Presidency University, but she was doing a project there. So initially I was surprised, like how you can do project at other university or at a research institute if you are studying at other university. And then immediately after coming back, I talked to the professor, Nandri Kalam sir, Mukul sir, literally everyone, to get me into some project fellowship, just project without any funding. And that was third year. So in the fourth year, Mukul sir talked with Professor in IIT Gandhinagar, and Nandri Kalam sir talked with professors in Professor D.N. Basu in the VCC. VCC is the Variable Energy Cyclotron Center. It is next to the Saha Institute of Nuclear Physics in Saltburn. So there I started working for a project. While doing that, I attended an international workshop. This was my first international workshop where I met these two people. This person works on particle physics and this person works on dark matter. So that was my first introduction to the dark matter. During this time period, I started going on several conferences and workshops to build up a network and to understand more and more how I can get a better PhD position, can do better research, and can get better research ideas. This is a tropical conference in cosmology and gravitation. Every year in West Bengal, at multiple institutes, they organize this conference. This conference, there are some very eminent physicists. For example, you can see there is Soumitra Gupta from ISCS. Mukul sir knows him very well. Yeah, he is absolutely amazing. So, and then there is Professor Narayan Basu from IIT Kolkata. Narayan from IIT Kolkata. And then there are Chetan Chatterjee from Presidency University. She was on AGN. Then there are other multiple physicists there. And the people who are standing in front, some of us are like this girl, she's right now in Poland. She's doing a postdoc. So from there I get an idea, okay, that I have to interact with more and more people and get to know about the field. And then in 2016, there was a page about to do research on gravitational waves. Because in 2016, that was the time when first gravitational wave was detected. So I thought, okay, I should go. And I also took some workshop on that, so I had the skill for the data analysis of gravitational waves. So for that reason, I wanted to go into IIT Madras, but I didn't get that. I got admissions from IIT Patna, IIEST, IIT Durgapur, and IIT Bombay, but that was for environmental science. And I was not interested in environmental science. It's a good field, but I was not interested. So at that time, I discussed with Farooq sir as well, and he told me that it is better to do your master, finish your masters here rather than going to IIT Patna if you are not getting any professor who has the same research interest as you. So I decided to continue my master's. So in 2016, I joined the VCCL project training. So all those master's students, they know that in the final semester, you have to submit a project presentation. I think that was in my time. I believe that is also same right now. So I was in the 4th year of integrated masters. I was the only first person from the 4th year who started working there. It was summer internship. But we know research doesn't need any funding. It is not limited by time. So I started the project in summer, but I was not able to finish in 3 months of summer. So I kept working at VCC after my classes. So my classes ends there around 4:30. And the VCC is approximately 20 minutes away from our university by bus. So from 5 to 10 p.m. I used to stay at the VCC and work there for the project. And there you can. This is another workshop which I attended from VCC. This was CNT workshop, Center for Nuclear Technology. This person who is standing behind the guy is my dear person. He was a scientific officer, nuclear physicist, under whom I started working. The project was not funded, but the project has really good idea. The concept was really good. The other person standing next is also a nuclear scientist by past. You might recognize two faces here. This is Mohammadullah, who was working under Hansa, and this is Mushid Dayas. Is I think in the 6th year of his PhD. Okay, and then there are some people from France. This was another workshop, and after that I went to Pulsar Astronomy Bootcamp. This was in Hyderabad, arranged by Brits Pilani. And here I met several people who are working in the gravitational wave astronomy. And yeah, it's very hard to recognize me here. And then there's another person from this other university. She is Vidisha Ghosh. I think submitted her thesis of PhD defense yesterday. Okay. So then I realized I get to know, okay, I need project and publication. So there I started the work. I finished my project in 2017. I graduated, and then my struggle started. In 2017, after finishing my master's here, I went to Delhi and prepared for CSIR and CSIR UGC NET and GATE exam. And after coming back, I qualified CSIR NET LS twice in December 2017, and then in 2008 I qualified GATE as well. But this was LS. And if you have lectureship, then the chances of getting GRF is extremely low. Because whenever you will go for an interview, there is a scarcity of funding. People don't have funding. So it will be good if you have GRF, then professor can easily pick. Okay? So that was not my case. I gave interview at multiple universities, did not get any opportunity there. So parallelly, I kept working with Dr. D.N. Basu. I published my first paper in an international journal. So this paper was about compact bifluid hybrid star. It got published in 2007, the time when I graduated from. This was the project which started in 2016 and was finished in 2007. So it took almost 1 year and a lot of hard work. But yeah, it gave a really good result. We published this paper. And from this publication, I have right now total 50 citations. And after that, when I get interested in gravitational wave, I went to my supervisor and told him that it would be great if we start working on gravitational wave. Because if we get something, it can be detected. So I started the second one. And that one got published in 2018, the Physical Review. So both of these are in national journals. And that made a really good impression on my CV. So the take home thing is that try to work on project and try to publish something. Okay? It doesn't matter whether you are first author or second author or fourth, not in the masters. But in PhD it matters, not in the masters. Then I realized, okay, I should start looking for study abroad because I have international publications, so I might get them. And then I applied for PhD and got offer from Michigan Tech University. And then COVID hit. And I got an email back from my supervisor there that due to COVID, we have cancellation of some fundings. So your funding is not sure, but you can come here and then we will think about it. And I was not ready to take that risk because I did not have that much money. So for that reason, I have to, wait for this. I say that I cannot join this. And then I got a PhD from University of Coimbra, Portugal. This one was about neutron star. Here the issue was, in Portugal, this university requires a transition from your university certificate to their system. Okay, our grading system is different than their grading system. So they wanted my result to convert into theirs. And for that, they need some fees. And the fees was 90,000 rupees for me. And at that time I was completely broke because there were other multiple situations happening at the same time. In my home, there was an accident. So we have gas cylinders in our home, right? My father was going to cook tea, because he loves tea. And I was not there. My mom was not there. We were at a doctor's appointment. There was a gas leakage. And because of that, the cylinder burst. And my father received 60% burn. So he was at the hospital. I was there, sitting at the hospital and doing my study, research, because life must go on. However, that situation, I survived that situation. But this thing everyone can relate. When you finish your master's or graduation, your parents will at least expect something from you. They will expect that you start working, you get a job, because you have to survive. And job market, everyone knows what happened in the time of COVID. People lost job. And what I did to pay for, in the US, when you apply for any university, you have to pay an application fee. And I did not have money for that, so I thought that I should start working. And then I joined two companies. One was Czech and other is Bartleby. I recommend everyone who has financial difficulties to look at these two companies. These two are not something different from your field. You all are physics students and some maybe engineering. On this company, Check, you solve one physics question and you get 155 rupees. And on Bartleby, you get 168 rupees. And the questions are fairly BSc level, master's level. You must be thinking how they are giving you money. So their clients are in the US and UK. So students there, they take online help from this website, and you are the subject matter expert. You will give the solution, and that solution will go to that institute, and company will pay you. And these two are really very big companies. You must be seeing ad of checks, not Bartleby, because Bartleby is a smaller company, so they pay more. So I was working in that every month, earning money, supporting my family, and so the time when I was applying for PhD, I had exactly 9,100 rupees, and that was my fees for Clemson University form, which I applied. And that year, once the COVID is done, I started getting admits. I got admit from 25 you have to spend your own money. And that money will go around 16 lakh, 17 lakh for a year. So that's definitely not possible. I again got a from Michigan Tech saying that he got the funding. And then I got the admit from Clemson University. I joined Clemson. So while you are shortlisting universities for study abroad, you should always categorize them as three categories. One should be ambitious. Ambitious means a place where there is a really good research going on, and you will feel yourself lucky to be there. And the second is medium, and third is low ranking. Clemson was in my first priority list because the research was really good there. So I joined Clemson. Now at Clemson, this is the benefit of becoming an international student. In this group, one person is American, two people are from Italy, two people are from Spain, my supervisor is Italian, and then all other people are American, one person is from China. So this is a very diverse group. And the professor, Marco Yellow, he has really strong profile. His citations are 60,000 right now, and he has a lot of NASA funding. And that was the reason why I emailed him. I actually emailed him in 2019, first time, but in 2019, this university required GRE physics, and I did not have GRE physics at that. When I applied for GRE physics, it got cancelled. So that reason I was not able to apply in 2019. And in 2020, he again gave me response that yeah, you can apply, you have a good profile. And at that time, GRE physics was not required in this university. They required only GRE general and total, which I will talk later about what are those tests. So based on that, I joined him. He has 4 postdoc students and total 10 PhD students. And the strategy is like PhD students work with postdoc students, and everyone helps each other. So that increases really good research output. And he is the only professor who has that many funding as student. So after that, this starts my research. My research starts in 2022, last year, not even in 1 year. So everyone knows what this thing is, right? What is this? Say louder. Yeah, you should be communicating. That's the reason. That's the way how you can get into research and networking. Networking is important. That's a black hole. That's a supermassive black hole at the center of M87 galaxy. My entire research is around this black hole. Around this supermassive black hole, there is something called AGN, active galactic nuclei. So the proper picture, before going into my research, we need to know about some terminology. One is supermassive black holes. They are just black holes which has mass billion times, like 10 to the power 5 solar masses, and they are mostly found in the center of galaxies. AGN is the region surrounding the black hole. So since the black hole is rotating and it is devouring everything inside it, so there is a disk formed around it. The disk is extremely hot because the particles collide with each other and release energy. Even they are so bright that they emit, the central part emit way more light than the entire galaxy. And that central part is called AGN, active galactic nuclei. And then there are 2 types of AGN. One is Compton thick AGN, Compton thin AGN. Now there is something written as NH. So NH is the hydrogen column density. So how we define density? Mass by volume. But if we think about number density is number of atoms in a unit cube, or number of people in one room. Both are densities. So this is number of hydrogen atoms in per cm square in unit area. This is the number of atoms. So what happens if you consider a black hole? Some of you might have seen a donut. So basically, if there is a black hole in the center, there is a region, a toroidal region around it of gas. That is called torus. And in the torus, so when the light is emitted, to clear the next slide. So this is the AGN me bird, and these are the jets coming out, which is galaxy. So if you look at this one, this is a supermassive black hole. Around the supermassive black hole, there are disks. This smaller disk is called agent. And just outside the agent, there is gaseous medium surrounding the agent. These are the dust. So when a light is emitted from here, it will try to cross this, right? So if it is too dense, then it won't be able to cross. It will get reflected. For that reason, each disk classified based on density. If it is too dense, that is too thin, and it is Compton thick. Because the scattering which happens is the Compton scattering, which you read in quantum mechanics, ascending quantum mechanics. So, in this agent, these are the jets. Now, the agents has different names based on which angle you are looking at. If the observer is here and he is looking directly at the jet, it will look like a very bright star or point object. Then it is called a blazar. If you look at this one, it will look really very bright and it has some significance curve, and at that time it is called Seyfert 1 galaxy. And if you look from this portion, like this, then it is called Seyfert 2 galaxy, little bit fainter. And if you try to look from this side, and it is Compton thick, you will not see anything. So the source will be absolutely faint. So, as I said, this is the torus, and just near the supermassive black hole, there is a region called corona. This is only a predicted model. We don't know about corona, whether the corona has any geometrical shape or what is its location. It's not that corona which messed up everyone's life. It's different. So the light coming from this disk interact with this corona and emit X-ray. So if you are holding an X-ray detector and pointing towards the galaxy, and you see that you are getting some X-ray photons, that means that the galaxy has region in it. And if a galaxy has an region, that means the galaxy is not that cold, and it has a supermassive black hole at the center. Okay. So this is all about alien. Now the project which I am working on. So the first project which I am working since the last year, and it is about to get published, that is NASA Swift Band 150-month hard X-ray band. I will explain in detail what is this band thing. And then another project I am working is the Photo Z project using SARA telescope, and the third one is hunting for Compton thick using NASA Chandra X-ray telescope. Now I told you what Compton thick is. Compton thick is basically Asian, which has the torus, extremely dense torus. Okay. So all of this projects are funded by NASA, and this project got accepted last year for funding and observation. So now we go. So the BAT is burst alert telescope. It was made to detect gamma ray burst. So whenever there is a burst, it will trigger the sensor and they will start looking at it. So this telescope was launched in 1980s and it has multiple components. This part is the back on which I work, and then this part is ultraviolet telescope and optical telescope, and then this thin filament, thin rectangular part is the XR, which is X-ray telescope, soft X-ray telescope. So hard X-rays are the X-ray with energy level, energy 15 kilo electron volt to 150 kilo electron. They are called hard. If the energy is beyond 200 kilo electron volt, then it will be counted as a gamma ray. Okay. So this is the telescope. This telescope observes the sky and gives the data, and the data comes to me and I have to analyze. So the main work is start here that this telescope has detected 1700 sources in its 100-month catalog, and I am working with 150 months. That means I am working with the data of 12 years of observation, which is a lot of data to analyze it. So my job is, since it has detected almost 2,500 sources, so it is looking at the sky and it suddenly detected a hard X-ray is coming. And now it noted down the location. So my job is to find out which object is the emitting hard X-ray. That means there is a huge possibility of getting some different object which we have never discovered before. So that is the exciting part about this. Also, so if it is detecting light from a galaxy, that means the galaxy has an agent. The galaxy, the object is classified as galaxy. But now I know and we know that that object is not simply a galaxy. It's the agent and it has supermassive black hole at the same time. So in that way, it's just like a child looking at the sky and trying to identify which is Pluto, which is Jupiter, which is Saturn. The same kind of, except you are on the screen. So in that way, we found agent. Now, obscured agents are the agents. So if you are looking from the sideways, you are not getting any light, any photon. So it will look like a faint source, and that is called obscured agent. So if you get obscured agent, so the light is crossing the torus and then coming to us. And if you keep looking at that source for, let's say, 3 hours or 4 hours, you will see how the light, the flux is varying with time. So in that way, you can tell how the density of the torus is varying. So, and based on that, you can tell about the geometry of space-time around the supermassive black hole. So surprisingly, we are not getting homogeneous density. We are seeing that the density is varying with time. That means there are some lump thing in the torus which we still have to explain, and we are trying to find out the explanation for that. That means the torus is not homogeneous. That means gravity might have some preferable points near the supermassive black hole, and that is our interesting work. So till now we got 75 galaxies which are alien, and we also found 2 objects which everyone previously knows that it is a star, and it is classified as a star everywhere. But we were able to find out that these are not a star, they are blazes. So remember what is blazer? Blazer is basically the agent you are looking for the jets. So it's looking very bright. At that time, the agent is called blazer. So we found out that those stars are not stars, they are galaxies, the supermassive black hole, very young galaxies. So since we are working with a lot of data, so we have to use some supercomputer facilities. This is the Farnmeter supercomputer which Clemson University has, and we use this to process our data in very few time. Otherwise, if we try to work on our laptops, it will take several days. Our laptop may crash. For that reason, we use this supercomputer. So these are the galaxies. As you can see, they are bright, but they are not that bright compared to the entire galaxy. But we found that they are emitting hard X-rays. That means these are AGNs. Both of them have AGN in the center. Similar way, there are other galaxies. This is a spiral galaxy. Is also emitting AGN, and this is more or less a Seyfert 1 galaxy. Because you can see you are directly looking at this. And then this object is also a galaxy, it's kind of very diffuse optical galaxy. So this is also has an agent. So these are the sources we got. And so that's the overall project. And this project is extremely large project. So we might be able to get several publications from this project itself, and we have to submit it within 2 months. And we hope that will get a lot of citation, because this bad X-ray catalog is the only hard X-ray catalog right now. So for 10 years, people are waiting to get data from this bad catalog. We will be able to provide that. Okay, so this is my first project. This is still continuing going on. We got some interesting sources which I have not mentioned here. because it's too soon to claim anything. There are some sources which was emitting hard X-ray in 2010, and then suddenly they start becoming fainter and fainter. And now they again started emitting in 2009. So at this point we don't know what that object is and what is going on in that region, because that object is inside something called dark nebula. That is the region of the space from where you get no optical light. So that is an interesting source, and we are still looking into that. What object is that? Okay, so now moving forward for the second project. This is the SARA telescope. This stands for Southern Association of Research in Astronomy. One is at Chile and one is at Mount Peak. So we use these two telescopes to measure redshift of blazar and aging. So redshift basically gives you idea about how far the galaxy is. If the redshift is very high, suppose 7, that will mean that the galaxy is almost 7 to 8 billion light years away. So the light you are looking at is not from now, it's from 7 light years away, that is from past. So using this project, we are trying to find out something called seed black holes. So in the beginning of the universe, we assume that there are some black holes which were produced at that time, but that's only a theory. But if we get a black hole or AGN with a redshift around 30 or 40, that will mean that that is the first quasar ever produced in the nature, in the universe. So we are trying to find out that. And apart from that, we are also looking at how far our galaxy is to find out more and more details about the galaxies, like how fast they are. Because redshift gives you a measure of their velocity, whether they are moving forward or whether they are moving towards you or away from you. But we all know that they are moving away because the universe is expanding. So using that, we can also make a Hubble diagram and try to calculate the Hubble constant. That's the next step for this project. Right now we are focusing more on the finding the redshift. This is the second project, and in that project we also use something called SWIFT-QO, which is nothing more but this same telescope, this part of the telescope. So optical and ultraviolet. We get data from this. So we just have to submit a file to NASA, and the file contains all the coordinates of the object we are looking at, and then the telescope observe that and send the data to analyze it. Then after SARA, the third project which I am using in the Chandra X-ray telescope. Chandra X-ray telescope was launched in 1999, and till now this is the most sensitive X-ray telescope. And as you may be wondering, this is Chandra. So this is named after Subramanian Chandrasekhar, the Nobel Prize winner in 1975 from India, who won Nobel Prize for his work on neutron star and Chandrasekhar limit. So this is named after him. This telescope, what it does, so we found the galaxies. Okay, we found that there are galaxies emitting hardest. So we got that, okay, it is an age. Now what kind of agent is that? To understand that, we send a proposal. Proposal means basically you write down like why you should look at a galaxy, what you can get from the observation. So we submitted a proposal to Chandra so that Chandra will orient itself toward that galaxy and start observing. So for each source, it will look at the galaxy for 3 hours. Take the data and then send that to you. So in that way, we are looking into 10 galaxies to find out whether they are quantum thick or quantum thin. The reason of doing that is because theoretically, the universe should be full of quantum thick aging. But it is not the case. Till now, we have only 32 quantum thick agents. So for that reason, we are trying to find out why and trying to increase the number of quantum thick. So for for that reason, this Chandra telescope will be giving us a data. The observation will start in January 24. Then I will get the data to work on. So these are the three projects, and all of them comes with money, so it's really good for me. So if you guys have any questions,